In nature, snakes have long held the title of fearsome predators. Their bodies move in silence, their strikes unfold with lightning speed, and their venom can subdue prey many times their size. These traits make snakes some of the most efficient killers in the ecosystem. But the balance is not always in their favor. In the harshest lands, from burning deserts to endless grasslands, certain species dare to challenge them. These animals do not simply avoid snakes. They do not only defend themselves. They hunt snakes and include them in their daily diet. They are the snake hunters, equipped with speed, endurance, and strategies to defeat one of the most dangerous opponents in the wild. The confrontation between snake and snake hunter is not only a battle for survival, it also shapes the fragile balance of nature, where every organism plays an essential role in the cycle of life. Deadly snake predators, survival battles in deserts and savannas. In the arid deserts of the American Southwest, life persists through special adaptations. Among these adaptations stands the roadrunner, a small bird with biological features that make it a formidable predator of this ecosystem. The roadrunner, Geococcus californianus, belongs to the cuckoo family, but it differs greatly from the typical image of its relatives. Instead of relying on flight, it chooses the ground as its primary environment. Its long, strong, and agile legs provide its greatest advantage, allowing it to reach speeds of up to 20 miles per hour. In a habitat where snakes, lizards, and other reptiles are common, speed and agility are vital for survival. The roadrunner's most visible strength lies in its hunting ability. It can approach prey quickly, strike with precision using its sharp beak, and restrain its opponent with the power of its legs. With smaller reptiles, especially snakes, the roadrunner can immobilize the head and kill by striking the prey against the ground. Its hunting efficiency makes it one of the few bird species that regularly includes venomous snakes in its diet. The roadrunner's survival does not depend only on speed and hunting skills. Its body structure also demonstrates close adaptation to desert conditions. Its compact body helps reduce water loss, which is a major advantage in a land where water is scarce. Its dark feathers absorb heat in the morning, allowing the bird to warm its body when day and night temperatures differ sharply. The roadrunner also develops unique behavioral traits, such as conserving energy during long activity periods. All these features create an optimized body for survival in dry environments. Within the ecosystem, the roadrunner holds an important balancing role. By controlling populations of snakes, lizards, and insects, it helps maintain stability among desert species. In fact, a single small bird can influence the structure of the entire desert ecosystem. Without this predator, reptile populations could grow unchecked and disrupt many other species. The roadrunner is not only a cultural symbol of New Mexico, it is also living proof of evolution and adaptation, where speed, strength, and precision have been refined to confront even venomous snakes. In the harsh landscapes of the American Southwest, the roadrunner secures its place as a vital link in the ecological chain. It remains vulnerable to larger threats, yet powerful with specialized traits in the constant struggle for survival. In the dry lands of the Chihuahuan Desert, the rattlesnake is one of the most dangerous predators. With a strike delivered in an instant and venom strong enough to paralyze prey within seconds, it often dominates the food chain. Its rattling tail is not only a defensive signal, but also a warning of readiness to attack any intruder. However, when the roadrunner appears, the balance shifts. Unlike many small birds that avoid snakes, the roadrunner confronts its opponent directly. Its greatest advantage lies in speed and observation. With powerful legs, the bird maintains a safe distance, waiting for the snake to reveal an opening before delivering a precise strike. Its reflexes are fast enough to evade the rattlesnake's strike, which lasts only a fraction of a second. In the confrontation, the roadrunner exploits the snake's weakness, complete reliance on the first attack. If that strike fails, the snake quickly loses advantage because its heavy body prevents rapid movement. The roadrunner seizes this moment, locks the snake's head with its beak, and pins it against the hard desert ground until the opponent is fully restrained. In the desert ecosystem, such battles play a critical balancing role. The roadrunner helps control populations of young snakes and small reptiles, while it also becomes prey for larger predators. This predator-prey relationship maintains ecological balance. The presence of the roadrunner alongside the rattlesnake demonstrates that even the most dangerous predators are not invincible. Each species carries its own strengths and weaknesses, and these interactions sustain the cycle of survival in nature. The battle between the roadrunner and the rattlesnake is clear evidence of the harsh yet precise balance of the desert ecosystem. On the African savanna, where sunlight strikes intensely and grasslands extend without end, the secretary bird, Sagittarius serpentarius, stands out as a distinctive predator. Unlike raptors that dominate the sky, the secretary bird spends most of its time moving on the ground. With a height of more than 3 feet and long, strong legs, it displays a unique hunting style rarely seen in the bird world. The greatest strength of the secretary bird lies in its legs. They are long and muscular, capable of delivering kicks strong enough to kill venomous snakes in an instant. Research shows that the impact of a single kick can equal the force of large mammals. When it detects a snake, the secretary bird approaches with steady steps, waits for the strike, and avoids it with quick reflexes. Immediately, it delivers a precise kick to the head or body, leaving the snake unable to fight back. Its ability to strike fast, with power and repetition, forms the core strategy that allows it to subdue dangerous reptiles. Beyond strength, the hunting strategy of the secretary bird is highly efficient. It does not soar to search for prey like eagles or vultures. Instead, it walks patiently across the grassland, scanning the ground with sharp eyesight. This method conserves energy and allows it to detect even the smallest movements. From insects and rodents to venomous snakes, all can become targets. However, in the savanna ecosystem, the role of the secretary bird is critical. By controlling venomous snakes and rodents, it helps maintain balance among populations. This is especially important in areas where snakes pose risks to many animals, including humans. By keeping snake numbers stable, the secretary bird contributes to the stability of the entire ecosystem. The secretary bird is not just another bird of prey. It is an essential part of the savanna's web of life, powerful enough to defeat dangerous reptiles, yet limited by its own evolutionary trade-offs. This combination of strengths and weaknesses creates the image of a unique bird. One that helps sustain the ecological balance of Africa's harsh grasslands. In ecosystems where venom is often seen as the ultimate weapon, the mongoose is a rare exception. With a body weight of less than 4 pounds, it does not have overwhelming size or exceptional speed compared to other predators. However, the combination of quick reflexes, a flexible body, and sharp teeth makes the mongoose a dangerous opponent of venomous snakes. The mongoose's greatest strength lies in its resistance to venom. Research shows that it carries a special mutation in nerve receptors, which makes the neurotoxic venom of many snakes less effective. This allows the mongoose to survive snake bites and increases its advantage in direct encounters. This trait, combined with very fast reflexes, enables it to approach and counterattack before the snake can fully use its venom. In hunting, the mongoose often charges with sudden speed, dodges the strike with agile movement, and then bites directly into the head or neck. Its sharp teeth and strong bite force allow it to subdue snakes within moments. Even with highly dangerous species such as the black mamba, speed and lethal venom are not always enough to protect the snake from this small mammal. Despite these advantages, the mongoose has many weaknesses. Its small body makes it vulnerable to larger predators such as raptors, hyenas, or jackals. Its venom resistance gives it an advantage against snakes. But it is not absolute. A strike to a vital area or a deep wound can still be fatal. Choosing venomous snakes as prey also means that mongooses constantly expose themselves to high risk, which many animals avoid. Compared to aerial snake hunters such as eagles or hawks, mongooses face danger at close range. Without wings to control distance, they must rely entirely on speed, precision, and their biological advantage. This difference makes mongooses an irreplaceable part of nature's hunting dynamics. In ecosystems, the presence of mongooses helps regulate snake populations, especially venomous species that could destabilize food chains. By controlling snake numbers, they indirectly protect many other animals and support the stability of habitats. At the same time, mongooses themselves are prey for larger predators, continuing the ecological cycle. The mongoose demonstrates that size or venom does not always determine the outcome in nature. The combination of biological evolution and hunting skill enables it to face and defeat some of the most dangerous predators. This gives the mongoose a special position in the animal world. Small in size, but powerful in maintaining ecological balance. Fragile in body, yet strong through the evolutionary advantages it carries. In the animal world, where venom, size, or speed often determine survival, the honey badger, Mellivora capensis, stands out for endurance and unique adaptation. It does not have a large body, nor does it possess great muscular strength, yet this small carnivore forces many dangerous predators to be cautious. The honey badger is widely distributed across Africa and parts of Asia, living in open woodlands, grasslands, and semi-deserts. Its compact body measures about 24 to 28 inches in length, but what makes this species a survival phenomenon are its specialized adaptations. The honey badger's most important strength is its thick, elastic, and tough skin. This skin reduces injury from bites and provides strong resistance to venom. A bite from a cobra or a mamba may cause temporary unconsciousness, but it rarely results in death. After a short recovery, the honey badger often resumes fighting. This biological mechanism is rare among mammals, making it one of the few serious threats to venomous snakes. In ecosystems, the honey badger plays important roles at multiple levels. By hunting venomous snakes, it helps regulate species that can threaten other animals, including humans. By breaking into beehives, it inadvertently aids in bee dispersal, contributing to biodiversity. The honey badger's presence highlights the complexity of natural balance, a small species with an influence far beyond its size. From a survival perspective, the honey badger shows that resilience and persistence can compensate for the lack of size or raw strength. It is not the strongest predator, nor the fastest, but endurance and determination secure its place in the food chain. In an environment filled with constant threats, the honey badger represents an evolutionary strategy built on toughness and unique adaptation. In the harsh deserts of North Africa, where sand burns during the day and temperatures drop sharply at night, only species with special adaptations can survive. The fennec fox, Vulpes zerta, is one such example. With a body weight of only 2 to 3 pounds, it has developed several traits that allow it not only to survive, but also to play an important role in the desert ecosystem. Its most distinctive feature is its very large ears, almost as long as its head. These serve two clear functions: dispersing heat to cool the body and amplifying sound. While most animals struggle with heat, the fox's ears act as natural cooling systems. At the same time, sensitive hearing enables it to detect vibrations beneath the sand. Including the movement of insects or reptiles. This ability gives it a strong advantage in hunting. Agility and body structure also support its survival. Thick fur on the soles of its feet protects against hot sand and reduces noise while moving. With a light body and quick reflexes, the fennec fox can approach prey without being detected. This is particularly useful when targeting small snakes, including venomous species such as desert horned vipers. Its presence demonstrates the adaptive diversity of animals, showing that even small species can support ecological stability in harsh deserts. The combination of acute hearing, agile movement, and low-risk hunting strategy makes the fennec fox a notable snake hunter in North Africa. Although limited by size and strength, it shows that survival in nature depends not only on raw power, but also on adaptation and efficient use of available traits. This makes the fennec fox one of the most distinctive species of desert ecosystems, where life persists in a narrow balance between extreme conditions and stability. The great bustard is a characteristic bird of the South African savannas, where low grasslands stretch to the horizon. It avoids dense forests and prefers open spaces, where its long neck allows clear observation of the surroundings. It moves primarily by walking and takes flight only when necessary, conserving energy in the harsh, expansive savanna. This trait supports survival where food availability is unpredictable. However, limited flight makes it more vulnerable to large predators. The great bustard shows strong sexual dimorphism. Females weigh about 24 to 42 pounds, with wingspans up to 8 feet, while males are much larger, with bulkier bodies and greater strength. Its plumage displays distinct patterns: grayish-white on the head, neck, and belly, with dark brown and black across the wings and back. This camouflage works effectively in dry grasslands, but is less effective in shrubs or woodlands. Its physical form and coloration help balance between foraging and predator avoidance, but also limit concealment in more complex environments. The great bustard is an omnivorous species. Its diet consists mainly of insects such as grasshoppers, crickets, beetles, termites, and scorpions, but it also consumes lizards, small snakes, and plant matter such as seeds, fruits, roots, and leaves. This broad diet allows survival during dry seasons when food sources are scarce. However, Its dependence on grassland habitats means that population stability is threatened if insect or plant numbers decline. Great bustards live alone or in small groups, showing clear territorial behavior. Males are aggressive in defending territories and securing mating rights with multiple females. Breeding usually coincides with the rainy season. Females lay about 2 eggs and incubate them for nearly 30 days. Chicks reach independence within 3 to 4 months. This reproductive strategy balances offspring survival with parental investment, but also increases vulnerability when rainfall is irregular or habitats are disturbed. The great bustard occurs across many African countries, including Namibia, Angola, Tanzania, Sudan, South Africa, Ethiopia, Kenya, and Uganda, showing wide adaptation to savannas and grasslands. Since 2014, it has also been the national bird of Botswana, reflecting both ecological and cultural significance. However, populations face threats from hunting and habitat loss caused by agricultural expansion. Conservation measures are necessary to sustain the ecological balance of Africa's grasslands. The southern ground hornbill is the largest species in the hornbill family, with a body length of 35 to 50 inches and a weight of up to 14 pounds. Its glossy black feathers contrast with bright red skin on the head and throat, while juveniles show yellow skin, helping distinguish age and social status. Its large, strong beak with a prominent casque is its main tool for hunting and breaking hard-shelled prey, from venomous snakes to turtles. It is a true carnivore, hunting insects, reptiles, amphibians, small mammals, and even dangerous prey, playing a key role in controlling populations in savannas and grasslands. Its hunting success is enhanced by group strategy. They hunt in groups of 2 to 8 individuals, coordinating to surround and subdue prey. Another adaptation is the ability to carry multiple prey items in the beak and bring them back to the group. This coordination increases efficiency, reduces individual risk, and requires long learning, making juveniles depend on extended training to become effective hunters. The southern ground hornbill is a sedentary species that forms groups of 5 to 11 individuals, usually including a breeding pair and offspring from previous years. Juveniles stay in the group for long periods, helping care for younger chicks and defend territory, creating a complex and stable social structure. Living in groups improves territorial defense and safety, while increasing survival in changing environments. But such complex social systems are sensitive to habitat loss and fragmentation because the disruption of a single group can affect breeding and hunting. Within groups, the southern ground hornbill uses loud calls to warn of intrusions and maintain order. These vocalizations are essential for communication and defense, but they require large, undisturbed territories to function effectively. The tawny eagle is one of the most important raptors of African savannas and grasslands. It has an impressive wingspan of up to 5 feet, a body length of nearly 30 inches, and a weight of about 4 pounds, combining strength with aerial maneuverability. Its vision is extraordinary, covering an area of up to 9 square miles with a field of view of about 275 degrees, allowing it to detect prey and potential threats even behind its position. This ability makes the tawny eagle an effective hunter and a key species in regulating populations of small animals on the savanna. Its earth-brown plumage blends with the environment, while juveniles show black streaks that indicate age within the population. The species can live up to 30 years, demonstrating longevity when habitats remain protected. However, dependence on open savanna habitats is also a weakness. Habitat loss or disruption of prey populations can reduce hunting efficiency and cause population decline. The tawny eagle has a highly varied diet, including small mammals, birds, reptiles, fish, and carrion. This omnivorous feeding behavior supports adaptation to different conditions. Controlling prey populations while contributing to decomposition of organic matter. However, it competes with other predators such as hawks and vultures, and sometimes faces pressure from larger carnivores. The tawny eagle usually lives in pairs. It builds nests with sticks and sometimes reinforces them with bones for strength. The female lays 1 or 2 eggs and incubates them for about 45 days. The chicks require extensive care from both parents to survive. Reproductive output is low, and slow maturation makes the species vulnerable when habitats are disturbed or when hunting pressure increases. The tawny eagle plays a critical role in the savanna ecosystem. Its precise hunting and exceptional eyesight help regulate small animal populations, limiting outbreaks of rodents and reptiles. The northern black korhan, also called the white-winged black korhan, is an endemic bird of grasslands and low shrub habitats in South Africa, Botswana, Lesotho, and Namibia. It has a body length of 19 to 24 inches, with plumage alternating between black and white, and distinct white primary wings that differentiate it from the southern black korhan, which is entirely black. Physiological features such as the red bill, bright yellow legs, a black crest on males, a gray crest on females, brown eyelids, and a throat marked with black spots provide identification and reflect adaptation to open habitats, where visual awareness is critical for survival. The northern black korhan primarily inhabits extensive grasslands mixed with low shrubs, where each individual or pair holds a territory of about 100 acres. The species is monogamous, although pairs sometimes gather in small groups to forage. Its diet consists mainly of insects such as termites, ants, grasshoppers, beetles, and spiders. This insect-based diet regulates insect populations in the grassland, contributing to ecological balance and reducing pressure on vegetation. Its ground-based foraging shows efficient use of open habitats while avoiding direct competition with other predatory birds. One of the main strengths of the northern black korhan is its adaptation to open grasslands, where running on the ground provides better escape from predators than flight. When threatened, it produces loud alarm calls that alert the pair or the group to danger and allow immediate response. This behavior demonstrates collective defense and increases survival rates in an environment with many predators such as snakes, eagles, and small carnivores. However, its ground-dwelling lifestyle is also a weakness. Ground nests are easily accessible, chicks are vulnerable, and flight is limited, especially in open ground or sparse cover. The northern black korhan maintains ecological stability through a simple but effective social structure. Pairs coordinate feeding, search for cover, and share predator information through vocalizations. This ability allows the species to regulate insect populations while creating a safety chain for vulnerable chicks. Such interactions highlight the role of the species in grassland ecosystems, where each organism contributes to biodiversity and ecological balance. Its strengths include flexible survival in grasslands, a varied insect diet, effective defense strategies, and rapid visual response. Its main weaknesses are ground nests and limited flight, which expose chicks and juveniles to high risk. Conserving the northern black korhan not only preserves the species, but also protects the ecological balance of African grasslands, where many other animals depend on insect populations and vegetation structures that this bird helps regulate. Nature can only be understood and valued when it is observed in its wild environment. From grassland runners surviving in arid deserts, to secretary birds striking venomous snakes, to eagles dominating the skies, to desert foxes conserving every drop of water, to honey badgers resisting danger, and to orcas thriving in polar seas. Each shows one fact. True strength does not lie only in claws, muscles, or venom. It also lies in intelligence, adaptability, and survival ability. Even snakes, symbols of danger, remain subject to this rule. They are important links in the chain but never invincible. When species challenge them, natural balance is maintained. The final message is clear. Wildlife cannot be reduced to human boundaries. Only in the free spaces that belong to them can these animals reveal their full strength and role, sustaining the cycle of life on Earth.